Section 2.3, writing equations of the line, or equations of lines. So the first form that we're going to be considering is the general form for the equation of a line. The general form for the equation of a line is in the form ax plus by plus c equaling 0. Note that all lines in the plane can be put into the general form. However, so that's good. However, every line has an infinite number of equivalent general forms. So because of this, we usually try to restrict the general form to be so that it only has one answer. We're not able to always do this, but if we are, then we put it into standard form. So if there exist numbers a, b, and c, which are integer valued, and such that a is greater than or equal to 0, and a, b, and c are relatively prime, meaning that the greatest common factor between integers a, b, and c is just 1, then this is our preferred form to write the general form for the equation of a line. And so if you're able to put into this form, then you should use this form. And then if you do that, then there'll only be one form. And so then it'll be unique if it's in this form. When do we use the general form for the equation of a line? Well, we use it when we're determining distances to lines. So for example, suppose you want to find the distance from some point x0, y0 to the line ax plus by plus c equaling 0. Then the distance is given by a x0 plus by0 plus c. And we'll put that in absolute value so that I'm sure that it's non-negative, because distance is non-negative, divided by the square root of a squared plus b squared. So that's the general form for the equation of a line. The standard form for the equation of a line has the form ax plus by equaling c. It's almost identical to the general form. It's just in this case, instead of having that the right-hand side is 0, I have that the right-hand side is equal to some constant. All lines in the plane can be put into the standard form, but just like the general form, every line has an infinite number of equivalent standard forms. And so, just like in the general form, we have a preferred form. It's the same as in the general form. If there exist a, b, and c, which are all integers, and a is greater than or equal to 0, and the greatest common factor between a, b, and c is 1, then this is the preferred form to write the standard form. We usually use these when dealing with systems of equations, of linear equations. And so if I happen to have more than one line, I will usually use the standard form for the equation of a line. Next, the slope-intercept form for the equation of a line. Y equals mx plus b, where m is the slope of my line and b is the y coordinate of the y-intercept. This form cannot be used for vertical lines. Usually, we'll use this when determining the slope of a line given by an equation. The point slope form for the equation of a line. Y minus y0 equals mx minus x0, where m here is the slope of your line, and x0, x1, y1 is a point on the line. Since we have an equation involving a slope, then the slope is x, therefore cannot be used for vertical lines. In general, this is the form that is the easiest to use. So in general, you'll always use this form, except for maybe some of the cases that I'm going to be enumerating today. And so those special sort of instances, such as in the general form, if you're trying to find a distance to a line, The standard form, if you're dealing with more than one line, the slope-intercept form, if you are trying to find the slope of a line given by an equation. But other than that, you would use just the point slope form for the equation of a line. The 2-point form. Well, of course, you would use it if they tell you to use that form. The 2-point form for the equation of a line is x minus x1 divided by x2 minus x1 equals y minus y1 over y2 minus y1, where x1, y1, and x2, y2 are two distinct points on the line. Now, this equation, we can put any line in the plane into this form if we assume the following. If we find that the denominator is 0, that must imply that the numerator is 0. And so if somehow the denominator is 0, then I have the numerator 0. Because, well, if you have some non-zero number equaling some number that exists, then it must be the form like 0 over 0. The intercept form. The intercept form for the equation of a line is the form x over a plus y over b equaling 1, where a is the x coordinate of the x-intercept, b is the y coordinate of the y-intercept. Now, since and a y-intercept must exist, then, and these both must exist, and they cannot be 0, then this cannot be used for vertical lines, horizontal lines, or any line that passes through the origin. So there's several stipulations here. You should use this when, well, you know you're both non-zero. So if you know both x and y intercepts and you know they're both non-zero, then you can put it in this form. It turns out actually this intercept form is going to be a standard form that we're going to be using for many equations. So for most equations that we're going to be looking at, it'll actually be in this type form. And so you'll see from later chapters that this type of form will become very familiar to you. Next, the symmetric form for the equation of a line. It's almost identical, actually, to the 2-point form for the equation of a line. It's just x minus x1 over a equaling y minus y1 over b. And again, if I'm dividing by 0, then I must have that my numerator is equal to 0, is identically equal to 0. The parametric form for the equation of a line, and this can be found by just letting this equal to t and then solving for x and y, is a system of equations telling us what each of the coordinates look like. And so x is equal to x1 plus at, and y equals y1 plus bt, where x1, y1 is the equation, is a point on the line. Let me see if I can, she raised her hand but didn't say anything. Okay. A horizontal line. A horizontal line can be put into the form y equal b. A vertical line can be put into the form x equal a. So let's do some examples. On page 229, let me do problem number 9. Write an equation of the line with the given properties. Your answers should be written in standard form. Okay. So I have here m equals 2. So I know a slope. and it says it's passing through the point -3/2, 1/2. So I know a point and a slope, so I should use the point slope form for the equation of a line. And so the point slope form for the equation of a line is y minus y1 equals m x minus x1. And so let's do that. Here, the slope is given, and the point is also given. This is x1, y1. And so I have y minus y1 equals m x minus x1. Subtracting 3/2 is the same as adding 3/2. Let me multiply 2 inside the parentheses. And so if I do that, I get y minus 1/2 is equal to 2x plus the 2's cancel, 3. Now I would like to get rid of the fraction. So let me multiply both sides of my equation by -2. And so I get -2x. Oops. 1 second. Let me control back of my screen. And 1 second. Okay. And so I have -2y plus 1 is equal to -4x minus 6. Let me add 4x to both sides of my equation and subtract 1 from both sides of my equation. And so I have written a line satisfying my given conditions in standard form. Let me do problem. Okay, so let's do the following. Oops. Okay, let's just move this a little higher. Okay. 1 second. Let's see if I can get control back of this. Okay, and let's move this up. So we're going to do problem number 67. And so in problem 67, we want to write an equation of the line that passes through the given point, 2, 5, and is parallel to the given line, 4x minus y equaling 7. Your answer should be written in the slope-intercept form. Okay, so let's do that. So I have here first thing I have to do is figure out the slope of this line. 4x minus y equals 7. So let me add y to both sides of my equation and subtract 7 from both sides of my equation. And so I've put this into slope-intercept form. Remember that we use slope-intercept form when we have a line given by an equation and we want to determine the slope. And so the slope here of this line is 4. I want to find the slope of line parallel to this line. Well, I know that the slope of a line parallel to a given line has the same slope. So now I want to use the point slope form for the equation of a line because I have a point and a slope. And so let's get one more page here. And so I have y minus y1 equals mx minus x1. Well, I know the slope is 4, and I have a point on the line. Let's call it x1, y1. And so I have here y minus 5. Move this out the way a little bit. Okay. So I have here y minus 5 is equal to, yes, 4. That's a 4 there. 4 x minus 2. Okay, so let me simplify this. Multiply 4 inside the parentheses. So I get y minus 5 is equal to 4x minus 8. Let me add 5 to both sides of my equation. So I get 4x minus 3. And so now this is in the slope-intercept form. And that is the form that we wanted to. And so this is my answer. Let me do the following. Let me just move this up a little bit. Okay. Let me move this up a little bit. So I want to do problem number 76. Write an equation of the line that passes through the given point and is perpendicular to the given line, intercept form. Okay, so let's do that. And so, again, this will be the point x1, y1. Okay, and so, I have it in the form x equals negative 3/4 y plus 5. So I want to find the slope of this line. So let me multiply both sides of my equation by negative 4. And so I get negative 4x equals 3y minus 20. Add 20 to both sides of your equation. So 3y equals negative 4x plus 20. Divide both sides of my equation by 3. So y equals negative 3/4 x plus 20 over 3. And so this is now in the slope-intercept form. Since we wanted to determine the slope of my line, we use the slope-intercept form. And so in this, see that the slope of my line is equal to -4/3. And so the slope of a line perpendicular to this line will equal its negative reciprocal. And so this will equal +3/4. So now I'll use the point slope form for the equation of a line. Y minus y1 equals mx minus x1. And so I have y minus y1, which is -5, 1. So -5 becomes a +5 equals, slope is 3/4 times x minus x1, which is 1. Let me get rid of the fraction. Let me multiply both sides of my equation by 4. Actually, let me not do that. Let me multiply the 3/4 inside the parentheses first. So y plus 5 equals 3/4 x minus 3/4. Let me multiply both sides of my equation by 4, just to get rid of the fractions for 1 second. So 4y plus 20 equals 3x minus 3. Subtract 20 from both sides of my equation, so 4y equals 3x minus 23. Divide both sides of my equation by 4, so y is equal to 3/4 x minus 23 over 4. This is in slope-intercept form. And that is the form that we want to write our answer. And so this is my answer. Okay, and so that finishes off section 2.3. Let me just check if there were, no, there was nothing typed in. Okay then, I guess that is it for today. And I will see you tomorrow.